Hello friends, welcome to our channel Red's Info. In this video, let us discuss one of the very nice questions from gravitation chapter. See, let us see what is given here and what you are asked to find in this question. It is given that the projectile is a projectile is projected with velocity kve in vertically upward direction from the ground into space. From the ground means from surface of Earth. V is where V is escape velocity and K is a constant which is less than 1. If A resistance is considered to be negligible, then the maximum height from the center of the Earth to which it can go will be by taking capital R as radius of Earth. Find out. So, as given, V, the velocity of projection is K into VE, where V is escape velocity. Okay. Now, so you can understand like the scenario by using this diagram. So we have the center of Earth, O, and this is the radius of Earth. So surface of Earth or ground, then take it as a point V, and from here you project your body vertically upward. It will go to maximum height h, and it stops. Stops means final velocity will be 0. So at point B it stops, and of course it will return back. Now, when it stops here, that velocity is 0 means kinetic energy are also 0. So at a height, so from the center at this height, it will possess an energy called only potential energy. Whereas at this point on the ground or on surface of Earth, because of the distance from center to the surface of Earth is r, it will possess potential energy, and also as we are projecting with this velocity, it will possess potential energy also. So what you can say is from law of conservation of energy, total energy at A is equal to total energy at B by applying the law of conservation of energy, and by considering this condition, we can write like this. Total energy is potential energy plus kinetic energy. So potential energy on surface of Earth, that is at point G means on surface of Earth is minus Gm1 m2 by R. So here one m is mass of Earth and another m is mass of object. Small m is mass of object by R is radius of Earth, plus half m is the velocity with which the object is projected, and the mass of the object is m. So its kinetic energy is half m square. So the total energy is this. So that is equal to at point B, our maximum height point. As velocity becomes 0, kinetic energy will become 0. So we can say as kinetic energy is 0, the total energy is nothing but only potential energy. So it is nothing but minus Gm1 m2. That is capital M small m by R plus H. R plus H. Okay. So by simplifying this, as small m gets cancelled, the small m term, they will get half V square equal to G capital M by R minus G capital M by R plus H. Now this, on simplifying further, we get half V square equal to G M H by R into R plus H. Now, so at this again after simplification, we can write like this: V square equal to 2 G M H by R into R plus H. Right here, as 2 Gm by R is nothing but escape velocity square, we can replace this with escape velocity square, and we can write it as V square equal to V square into H by R plus H. But as we want H, so we can write by taking this H common out here, we can cancel out this H and H. So V square equal to V square by R plus H. So this further you can write like this: V square equal to V square by R plus R by H plus 1. So R by cross multiplying, by taking this R plus H here and by V square to the denominator, we can write R by H plus 1 equal to V square by V square. And this further again, we can write it as R by H is equal to V square by V square minus 1. This plus 1 comes to the right side, it becomes minus 1. Right now, as we want H, we again by cross multiplying, if we bring it H here, this entire term comes to denominator and becomes R by V square minus 1. This is the maximum height required from surface of Earth or from ground. But we are asked to find what is the maximum height from center of Earth. So for that purpose, we have to just find out even in this, by when you take velocity V is kV square. By substituting this, we get H is equal to so by substituting this V and squaring and simplifying, just V square cancel, we will get 1 by K square here. So 1 by K square minus 1. This further on simplifying this, we will get 1 minus K square by K square. Is K square goes to numerator and becomes R K square by 1 minus K square is the height from the surface of Earth, from ground. But we want the height from the center of Earth. So height from center of Earth is in the figure, if you observe here in the diagram, height from center of Earth can be taken as H dash is equal to R plus H. H you have got, now the entire height can be taken as R plus H. So by taking this, you can take it as height from center of Earth is H dash equal to R plus H. where r plus h is this, and this further again simplifying, that is by cross multiplying. If you simplify it further, r into 1 is r plus minus r into k square is minus r k square, r minus r k square plus r k square divided by 1 minus k square, and again by simplifying, by cancelling this, we'll get r by this. H dash is equal to r by 1 minus k square. This is the answer for our question, r by 1 minus k square. So which option is right? Option C is the right one. Did you understand this, guys? So if it is required, you can take the screenshots of every page and just you can go through once again. You can do it in very short and few less steps only, but for understanding purpose, I have taken every step by step. Okay, take the screenshot and go through it and try to do as short as possible. Here I would like to give you one what you call in short. What is that alternate method? There is no other method. This only, but I have in reduced steps. I can do it. I will give you an idea here. See here. So as not like alternate method, alternate way of doing it. So here, just here, this step, from this step, if you start here, instead of simplifying this way, we do the simplification in the other way. We will get within few less steps. How to do that? Let us see here. So by taking this here, and here v is nothing but kv. kv. So if you square this, you will get k square v square half into k square v square equal to this. But here v is escape velocity, that is equal to square root of escape velocity is square root of 2 gm by r, or v square is equal to 2 gm by r. So by substituting this here, you can rewrite this as k square by 2 into 2 gm by r is equal to gm by r minus gm by this r plus h. We will take it as h dash, that is the height of the object at maximum height from center of earth, h dash. Directly can take this here. Okay, now again by simplifying further, if you get here k square, 2 cancel, k square gm by r, here gm by r, this gm by r, if you take it here, you get r. If you bring this k square gm by r to the right side, and if you bring this negative term here onto the left side, it becomes gm by h dash is equal to gm by r minus k square into gm by r. So the gm by r, if you take out, you will get k square minus 1. Is that right? Just either way, like actually it is like 1 minus k square here. If you bring it here, it becomes a minus k square. So here, small correction here, you will get 1 minus k square, you will get. Okay, not k square minus 1, 1 minus k square. Otherwise, here negative sign should be there. Okay, that is 1 minus k square. Now, on simplifying further, this denominator part, we have to take it as 1 minus k square. 1 minus k square will be this. So h dash is equal to, from this by cross multiplying, you will get, what is this? 1 minus k square by r is equal to 1 by h dash. So h dash is equal to r by 1 minus k square. R by 1 minus k square. This is your answer. R by 1 minus k square. Yes, r by 1 minus k square. This is the correct option. I hope it is clear for you guys. Okay, then just I'm winding the session. Take care, everyone. Jai Hind.